Welcome to Genique. In the previous class, we have seen the flux leaving any closed surface. That means the applications of the Gauss law and Biot-Savart's law and the electric field intensity due to the point charge and the magnetic field intensity due to the point current element and the electric field intensity due to the infinite length line charge and the magnetic field intensity due to the infinite length current carrying wire. Okay, so that is the electric field, okay, and magnetic field. So here it is a new question here. Given the potential function B is equals to 4 cos theta divided by r square, find the electric field intensity at 2 pi by 4 comma pi. Okay, so in the previous class we have seen how to find the electric field intensity due to the current carrying, due to the point charge and the point charge and the line charge. Okay, but here he has given some new function. What is that function? Potential function. Okay, potential function given, we have to find the electric field intensity. So here we cannot use the expression whatever we have derived in the previous class. Okay, so that's why we have to go for this concept now. So what is, first of all, for finding the electric field intensity, first of all you have to know what is the potential. Okay, so then only you should be able to find the electric field intensity. Okay, so what is the potential? So potential or a voltage, potential is also be named as the voltage. So how can you find the voltage? What is meant by voltage? Okay, so what is a voltage or a potential? In general, it is a potential. It is, observe this, potential is nothing but the work done in moving a unit charge to a point in the electric field. So this is the definition of the potential. So what is the definition of the potential? The work done in moving a unit charge to a point in the field. So first of all, there must be the field. Okay, so suppose if you assume any field, electric field, okay, so let us assume some field is existing. Okay, inside this some field is existing. Let us suppose inside there is some electric field is existing. How the electric field exists? The electric field exists due to some charge. Okay, we may assume that some charge is present. So due to this charge, the electric field is existing. Okay, so how the electric field will be? The electric field will be radially outward. Okay, suppose I am taking the point charge. Okay, this is the electric field, right? So now it is the electric field. So in this electric field, what I have to do? What is the potential? Is nothing but the work done in moving a charge, in moving a unit charge to a point in the field. Okay, so suppose one charge is there. Let us suppose some unit charge, some QE or some Q. Okay, some Q is there. Okay, so I want to move this point charge to this place. Okay, the work done in moving is in this direction. I have to move this. So to move this charge in the opposite to this direction, what I have to do? I have to do some work to move this. Okay, so that work is called as the potential. Okay, so what is that work? The work done is equals to, what is the potential? It is indicated with V. V is equals to W by Q. V is equals to W by Q. What is W? W is equals to work done. Okay, W is equals to work done. What is work done? work done is equals to what? The force means what I have to do? I have to do some work means force into distance or displacement. Force into displacement. So a piece of work done is equals to what? The force into displacement dl. Let us suppose some distance dl is moved by using this force. Okay. So one thing you have to know that what is meant by force? The force exerted on this charge while moving here, the force exerted by this electric field. Already you know, this is the electric field. It will exert some force on this. Okay, while it is coming into this field. Okay, so that is called as the force. Okay, so the force on this charge due to the electric field can be written as what? This will be equals to F equals to E into Q into dl. And one more important thing is how the force will be. The force will be in this direction. Understand? The force will be in this direction. But it is not the force exerted by the electric field. But what I have written here, the force I have to see. If I want to move this point charge into the field, I have to do some work with some force which is equivalent to the opposite to the force exerted by the electric field. So I have to apply the force in opposite direction to the electric field. Okay, so that's why I have to write minus. Okay, this field is what? F equals to E into Q. This field, this force is what? This force is F is equals to EQ. But I have to do in this direction work. Okay, so that's why I have to put a negative sign here. So now, what is work done? The total work done. If I integrate this, what I will get? Minus Q integral E dot dl. dl is what? It is a vector. dx ax, dy ay, dz az. Okay, so from this, what can I write? So W by Q can be written as what? Work done per charge is equals to, it is equals to the voltage. The work done per charge is equals to voltage. So this will be equals to minus E dot dl. It is a vector, but it is also vector. It is also vector. Electric field is vector. Already you know. Electric field is a vector. Okay. So this is called the potential. Okay. So this is the potential. Now we came to know that this is the potential. Understand? So it is what? It is a vector quantity. So from this what we can write? From this what we can say? So what are the units of this? The units of this are volts. Or what is the work done? Work done per charge. Work done per charge is equals to work done joules per coulombs. Joules per coulombs. These are the two units. Okay? Joules per coulombs. So that means work done per basic cause. Voltage is nothing but work done per basic cause. Okay. So this is the potential. So now from this what I can write? So this is what? It is a scalar quantity. So scalar quantity, the potential is nothing but it is a scalar measure. It is a scalar measure of E field strength. It is a scalar measure of E field strength. Okay. So electric flux density is a vector quantity. Electric field intensity is a vector quantity. But electric potential is a scalar quantity. You should remember this. Okay. So this is the voltage. Understand? So now, so this is the so that means what? It is what? The work done. It is also already we know work done is nothing but what? Some vector into integral of some vector into dl. Suppose if you put a closed surface here, we should not put a closed surface here, because if you put a closed surface, if we put a closed line integral here, what happens? It will be equals to 0 from the Maxwell's equation. Okay, suppose in the overlook, if you put one closed line integral here, what it will be? It will be 0. So that's why you should not put it. Okay. So it is a work done. So if you put the closed line integral means the work done will be 0. So this is the potential. Suppose if I want to, so from this what I can write? So observe this, it is V, it is E dot dl. So from this I can write what is V is equals to dV. So what is dV is equals to, it will be equals to Q minus Q into, sorry, suppose if I derivate this V, then what I will get? Minus E dot dl. It is a vector. It is minus E dot dl. Okay. So if you observe this, what is E? So from this what I can write? E is equals to minus dV by dl. Observe this, dV by dl. Here you have to notice one thing, but it is what? It is a vector quantity. Observe this, it is a vector, it is a scalar. Understand? So what is E? Electric field intensity E is equals to minus dV by dl bar. Understand? See, observe this, it is nothing but what? dl is equals to dxx dy/ay dz/az, dxx dy/ay dz/az. So what is the meaning of this one? dx ax dy ay dz/az means it is a vector. That means it is showing that the variation of this total expression, showing that the variation of the voltage in the direction of x, the variation, the rate of change of the voltage in the direction of x plus in the direction of y in the direction of z. That means I can write a del here. Understand? See, observe this. So I cannot go to the details now. See, observe this, it is a vector now. It is a vector. So vector means it is differential length in the direction of x, in the direction of y, in the direction of z. Okay. So from this what I can write? It is a scalar quantity. I am derivating with respect to this vector operator. What is this vector operator? Del operator only. So I can directly write E is equals to minus grad V, del V. Okay, E equals to minus gradient of V. So it shows what? It is the maximum rate of change of potential. What is the gradient? Maximum rate of change of potential Okay, it is the maximum rate of change of a potential. Okay, the gradient represents what? It is called as what? It is a gradient. Which gradient? The potential gradient. So electric field can also be called as, it is a potential gradient. Understand? So now we got the electric field. We got the electric field. Observe this. So we have to find the electric field intensity. We have to find the electric field intensity due to this. Okay. So now we have to find the gradient of the scalar quantity. Okay. So if you find the gradient of the scalar quantity, the problem is over. Okay. So now observe this. If you observe this, it is given in which coordinates now? Okay, it is given in which coordinates? Gradient operation. Okay, the gradient operation. So what is? So it is given in which coordinates? So if it is in Cartesian coordinates, it would be very simple for finding gradient. But here it is somewhat difficult to find the gradient. See, already we have know the shortcut method by using the scaling parameters. Okay. So now observe this. It is given in what? It is given in the spherical coordinates. The spherical coordinates. It is given in spherical coordinates. Okay, because r theta phi. R theta phi is given, means spherical coordinates. That is also given in spherical coordinates. Understand? So now how can we write? So we don't know how to write the gradient operation in the what is E? E is equals to what? Minus gradient of V. So we don't know how to write the gradient operation in the spherical coordinates. So suppose if you take any vector A bar is equals to AU plus AV plus AW, then the gradient of this, it is a scalar quantity, right? So gradient can be operated on a scalar quantity. Okay, you should not do that. Okay, it is a scalar. Let us suppose V is any scalar. What is the gradient of V? Gradient of V is equals to, in the generalized formula, 1 by H1 dou V by dou U AU plus 1 by H2 dou V by dou V AV plus 1 by H3 dou V by dou W AW. So it is very important and very useful also everywhere. Okay. So from this it can be applied for any of the coordinate system. Okay. So from this, observe this. It is V. See, it is V means this V. This is a scalar. Okay. Write this a big V. Okay. Or otherwise, you can take any other notation also. Okay. So observe this. So from this, what is E? E is equals to what? Minus. It is in spherical coordinates of 1 divided by minus is there, 1 divided by H1. H1 is what? H1, H2, H3 is 1 R sin theta. What is H1? 1 divided by 1 dou V by dou R. Okay, what is V? Write directly. Dou by dou R of V is what? 4 cos theta divided by R square plus 1 divided by H2. H2 is R. Dou by dou theta of 4 cos theta divided by R square plus 1 divided by R sin theta dou by dou phi of this one. I am writing here. Next term is 1 divided by R sin theta. 1 divided by R sin theta because 1 by H3. Dou by dou phi of 4 cos theta divided by R square. Observe this. So this is the function and this is the function. Observe this and this is the function. If you observe this, it is the function 4 cos theta divided by R, it is partially derivated with the phi. That means what? It is 0. So from this, it can be written as minus dou by dou R of 4 cos theta is taken out. Okay. So 1 by R square, the differentiation of 1 by R square is minus 2 divided by R cube. Minus 2 divided by R cube plus 1 divided by R. Okay. Now what is this? 1 divided by R is constant here. You can write R square. It is R cube. Dou by dou theta of it already it is 4 there. Cos theta. Cos theta for cos theta. What it will be? It is minus sin theta. Understand now? So now if I multiply this, what I will get? It will be 8 cos theta divided by R cube. 8 cos theta divided by R cube plus 8 cos theta divided by R cube plus 4 sin theta divided by R cube. Okay. But what I have to find? Already I got the electric field intensity. This is electric field intensity in terms of the spherical coordinates. So next, what I have to find? The electric field intensity at this point, where 2 pi by 4 comma pi. So what is this? If you observe this, this is r, this is theta, and this is phi. Okay, this is r, this is theta, and this is phi. So now this implies this will be equals to what? 8 cos theta. Cos theta is cos pi by 4. Cos pi by 4 is what? 1 by root 2. 1 by root 2. It is r cube is what? 8. So this will be 8 root 2. Sorry. Observe this. Okay, we forgot one thing here. What is that? It is dou v by dou v. It is a dou v by dou v au. So what is the expression? The expression was what? Grad v is equals to 1 by h1 dou v by dou u au plus 1 by h2 dou v by dou v av plus 1 divided by h3 dou v by dou w AW. So this is the expression, right? So I have to write the unit vectors also. Okay, I have to write the unit vectors. Forgot A5. Okay, so here it is AR, this is A theta, it is A5. So this is AR, this is A theta. It is A theta. So 8, it is AR plus 4. 4 means it is 1 by 2 root 2 A theta. So this is the electric field intensity at the given point. Okay, you can further simplify this. Observe this. What it will be? 1 divided by root 2 AR plus 1 divided by 2 root 2 A theta. So that means what? It is a vector quantity. Already we know what is this? Electric field. Electric field is a vector quantity. Understand? So 1 by root 2 AR plus 1 by 2 root 2 A theta. So like this, we have to find the electric field intensity. So in this question, what we have learned? So how to define a potential we learned. So what is the potential? We came to know. Okay. So like this, you have to solve. So suppose if the point charge or line charge is given, already we approached. Suppose if the voltage function is given, you have to take the gradient of a negative gradient of the potential function. Okay. So like this, you have to observe. Okay, thank you.